Now I'll show you another way to have EF Core perform an update for objects that are not being tracked. Most commonly, this will happen in a disconnected application, like a web app. This time, I'll use EF Core's update command, which explicitly tells the context to set its state to modified. This is very different than making edits on the fly to an object that EF Core is tracking, as you've been seeing so far. To show you this method in a way that makes sense and is more like how a real application works, I've created a set of methods that are similar to the workflow of a web application. First, find that author. This method takes as a parameter an integer representing the ID of an author that you want to find, and then retrieves it using find and returns the resulting author object. A second method, save that author, takes an author object, calls the update method of the author's DB set, passing in that author, and then calls save changes. And the third method coordinates the other two, telling find that author to get the author with ID 3, and if the author's first name is Julie, change it to Julia, and then send the object, which I've just modified, to the save that author method. Notice that I'm explicitly instantiating new pub contexts in the find and save methods. What that means is after the author is retrieved in the find method, its short-lived context that I instantiated gets disposed. So if the context no longer exists, there's nothing tracking that author. So there's nothing tracking that author when I'm back in the coordinator method and it makes a change to the author object. Then when I pass the author object into the save method, we get a brand new context instance that's empty. It's not tracking anything. It doesn't know anything about this author. It doesn't know that the author came from the database, and it doesn't know that I made changes to it. So instead of calling dbSetAdd, which would think the author needs to be inserted into the database, which would create some problems, I'm using the update method. And the update method does two things. First, it causes the context to begin tracking the author, and at the same time, it instructs the context to set the state for that object to modified. Here's the debug view again, showing everything the context is aware of. And we see it knows about the author, including its ID, and because we told it about the state specifically by using the update method, its state is set to modified. When I call save changes, we get an update command in the database, and the first name in that row is now Julia. If you recall, when I did the earlier updates, while the context was tracking the authors, the update command only had the ID of the author to update and the value of the modified name. And here, I also only made one change to the author, changing the first name. But this update command is updating the last name as well, even though I didn't edit it. Remember that this was a new context that had no idea of the history of what happened to that author in our code. The update command has no way to know what got updated, so it tells the change tracker that every field is modified. And if we go back and look at the long view in the debug view before we called save changes, you can see that the change tracker has marked both the first name and last name properties as modified. It's the only way to be sure that you're getting all of your changes to the database. As you get to more advanced scenarios with EF Core, it's important to understand this, especially in nuanced situations where it could have an adverse side effect on data or performance. But in common scenarios, this is a perfectly good way to handle the update. If there was a context tracking the author at the time that I made the edit, then you wouldn't need to call the update command because, as you've seen, save changes calls detect changes and the context figures it out. But in scenarios such as disconnected applications where you're passing objects around, it will be up to you to somehow inform the context about that state. So your software logic does need to know when something needs to be updated or added or even deleted. The update method is the simplest way to do that. There's one type of data operation you haven't seen yet, which is deleting data. If you're new to any version of EF Core, even the original Entity Framework, I'll warn you that this isn't intuitive at first. Most of us assume we can just say delete some ID, just like we can find an ID and execute it. And we could do that with raw SQL or stored procedures, which you'll see later in this course. But if you consider how the context works, the standard delete workflow will hopefully make sense. The context needs to be tracking an object in order to send a command to the database when you call save changes. And it's the same for objects that you want to delete. That makes it possible to let the context know it needs to be deleted, and then you call save changes. And teaching you about deletes lets me finally get rid of that extra Julie Lerman in the authors table. I'll do that with the one that I just changed to Julia. But I also want to point out that this has an ID of 1, and looking at the raw data in the database, there are no books tied to that author record. We'll learn more about deleting related data further on in the course, but this gives me an easy example to start with. In my delete an author method, I'm first retrieving that author from the database using the find method because I know the ID. And even though we just looked at the database and I know that the record exists, I'm also doing a null check before moving ahead. If the result of the find is not null, not only do I have the author object, but the context is now tracking it. The method for deleting is not the word delete, as you might assume. It's remove. And remove aligns with other .NET methods for removing items from lists or collections. And it does make sense here. We're removing the object from the DB set, and it's up to save changes to turn that into delete from the database. So the code that I'm using now is context.authorsRemove, and just like the add method, you pass the object that you want removed as the method's parameter. When I hit that code in debug mode, I want to pause and show you the debug view so you can see that the context is immediately aware of the deleted state of the object. Just like calling the add and update methods, the remove method triggers the context to change the state. Next, my code calls save changes, and with this, EF Core sends a parameterized delete command using the value of the primary key as its only parameter, then sends the row count back to EF Core. And looking at the authors table in the database, that row for Julia Lerman is indeed gone. There are other ways to simplify deleting. For example, instead of querying for an object, you can just create an instance with only the key populated, or you can use stored procedures or some custom code. And there's yet another path for handling deletes, which is referred to as soft deletes. It's a more advanced pattern, and therefore I won't be covering it in this course, but do look for a link in the resources at the end of this module for information about implementing soft deletes with EF Core. And when EF Core 7 comes out, there's a new feature coming called bulk updates, which should allow you to update or delete objects without retrieving them first. You've seen a little bit of code where I'm working with multiple objects already. Let's look at some more features of EF Core targeted at this capability. So far, I've used the add method to add one object at a time to the context, and the update and remove methods as well take a single object. But you might have to add multiple items at a time. Imagine that the publishing company just bought another tiny publisher that only has 5 authors. And this is a really lucky publisher with some amazing writers. I could call add 5 times, but that's kind of a drag. Instead, I'll take advantage of the add range method, which allows me to pass in multiple objects. In this insert multiple authors method, I'm using add range and then on the fly creating an array of the 5 new authors. I'm unaware of an upper limit on add range. I'm just using 5 because that's sufficient for this demo. Note that this method exists only for convenience. It doesn't have any performance advantage or disadvantage over just using the add method repeatedly. One convenience, though, is that you could pre-create the list of objects that are going to be passed in. So here's one way to do it where I'm just creating the list and pushing it into add range. But even more interesting is that you can pass a list of objects around in your code and then just push this list into add range directly, as I'm doing in this insert multiple authors passed in method. And do note that the delete and update methods also have a delete range and update range counterpart. You can also use the range methods directly on the DB context. In addition to the benefit of the DB context methods enabling you to write generic code, the DB context range method also allows you to pass in various types at once. So it doesn't have to be a list of authors. It can be a mix of types: authors, books, widgets, contacts, whatever. The context can discover what each type is and create the appropriate entity entry object. Okay, you're probably waiting for me to hit that Save Changes line. Let's do that and take a look at the SQL. Whoa, something new has happened. I didn't get 5 insert commands. What we're looking at here is a batch command, also known as a bulk operation. Down at the bottom of this command is a long list of parameters that includes the first and last names of each of the 5 authors. And the SQL at top is taking advantage of a SQL Server feature called merge. Let's look at what follows. It's gathering up the parameter values in first and last name pairs, then calling insert first name and last name for each pairing. Why did this happen now when before it just sent multiple commands? EF Core supports bulk operations, and after a lot of performance testing with a SQL Server provider, the EF Core team determined that there is a threshold of 4 records. Below the threshold, sending individual commands seems to perform best, but with 4 or more operations, batching them up gives better performance when you're adding up the effort that EF Core is making and what's happening in the database. So the database provider is responsible for specifying that threshold. In fact, if you were to look at the internal code for how the SQL Server provider sets up batching, there are a number of default settings here, such as max parameters allowed in a batch and even max batch size. And you can actually configure a number of these settings when you're configuring the provider and connection string for your context. But tuning your database performance is definitely not a topic for this course. But I did want to be sure you know that you can have some control over that. I also want to point out that because this operation is performing inserts, there's logic in here to gather up all the newly generated IDs and return them to EF Core. The bulk support is not limited to similar objects or even similar SQL operations. Here's a method where I'm adding some more authors, and in the same method, I'm also retrieving one of the books I inserted at the beginning of the course and modifying its name. Since the context is tracking that book already, I don't need to call update. And then when I call save changes, that triggers the batching. All of the parameters from the new authors and the updated book are here, and it's performing that merge insert on the authors, returning the new IDs for the authors, then performing the update on the book and returning the row count. So there you can see the bulk support handling different operations and different entity types all at once.